A modern smartphone can do the kind of things that no supercomputer could do even 2 decades ago. If a computer scientist from the 80s had been told about the features of a common AI tool today, he would probably have laughed it off as unrealistic. Because the computers of the past were as big as houses and their performance was very slow. But that expensive and gigantic technology has over time reached unimaginable levels of advancement, like today's smartphones or artificial intelligence. The main driving force behind this is the continuous development of hardware. Transistors, the tiny electronic components inside microchips used in technology products, are improving day by day. Many people may wonder what a transistor is. A transistor is a type of small electronic switch that controls the flow of electricity and sends signals to the computer. The more transistors a chip has, the more complex the chip can perform. Today's video will discuss how our everyday technology products are becoming smaller but more advanced day by day, and how modern AI technology has become possible. Nowadays, when we talk about AI, we talk about neural network data or models. But we rarely feel a fundamental question, and that is where this power of AI comes from. Why did what was impossible in 1970 become a common reality in 2026? To find the answer to this question, we have to go back to the birth of the microchip, when a few thousand transistors on a chip were a technological marvel. No one could have imagined that one day, billions of transistors would be placed on a small chip and its performance would surpass the limits of human imagination. In 1965, Gordon Moore observed that the number of transistors on a microchip was doubling approximately every year. He later revised this to say that it was doubling approximately every 2 years. The fact that computer chips are getting smaller and more efficient is not a natural or astronomical phenomenon. Rather, it is a sign of the continuous improvement of industrial technology. Our entire digital world is based on binary numbers, 0 and 1. Transistors control the electronic switches of 0 and 1. Therefore, as the number of transistors on a chip increases, the processing power of the chip increases. As a result, the speed of the computer increases and more power is available at a lower cost. At the same time, more functions can be added in less space. According to Moore's law, since the number of transistors doubles every 2 years, the devices become smaller in size. This continuous improvement has led to computers the size of large rooms being placed on a table, and now computers have reached the size of the smartphones in our pockets. Not only that, but many smartphones today have chips that are much more advanced than the kind of computers that NASA used to send people to the moon in the late 1960s. Various industrial organizations have also utilized this trend of Moore's law in research and investment. As a result, Moore's law has changed the course not only in the world of technology, but also in the global industrial management map.